Hello everyone and welcome to another video. Today I'd like to talk about 2D plotting in Mathematica. I'm going to assume that the audience has some basic working knowledge of Mathematica. If you're new to Mathematica or would like a refresher, please check out our Getting Started with Mathematica tutorial before continuing on. There's a link to this in the description of the video. So today we'll show how to generate some simple two-dimensional plots in Mathematica. This is designed to be an introductory foray into plotting and will give you enough to start exploring plotting on your own. If you're interested in 3D plots or more complex 2D graphics, we have separate videos that cover these topics. So, in terms of an agenda today, what I'd like to do is let's start talking about using the plot function in Mathematica. We'll look at adding some extras to this as well, namely how to decorate a plot as well as setting axis limits. This leads into a discussion on how to generate multiple plots on the same set of axes. We'll also look at other functions, mainly the ListPlot function, as well as a couple of other interesting 2D plotting functions like DiscretePlot, Histogram, and Pi. So, if all of that sounds good to you, why don't we jump into Mathematica and dive in. Alright, so here we are with a blank Mathematica notebook. Let's just go ahead and zoom in a little bit so it's easier to see, and let's go ahead and create a title for this notebook and call this 2D Plotting in Mathematica. Now, the first thing we're going to do here is let's go ahead and just start a section here and talk a little bit about how to go about doing plotting in Mathematica using the plot command. So, plot is actually Mathematica's go-to and one of its most versatile functions for generating two-dimensional plots. It's very simple to use. What you do is you just call plot, and then you pass it a function you'd like it to plot. So, for example, I don't know, let's do something like, how about t times cosine of t? And then I'm going to put a comma here, and now I'm going to specify the range of t values over which I would like to plot. So, I'm going to say I would like to plot t going from 0 to, how about, 4 pi? And I'll close that curly brace, and I'll close the plot command. And now if I shift enter this, here we go. This generates a plot. It's very easy. We can actually go ahead and even decorate this plot now. We can go ahead and do things like maybe we would like to add some labels to the x and the y axis. So the way plot and actually a lot of other plotting functions or graphics functions in Mathematica work here is up here, this is the meat of the syntax, right? Now, if I put a comma in here and I start listing some other extra parameters, for example, like axis label, let's go ahead and have the label here to be the x-axis to be t, and then the y-axis might be something like f of t. And I'll close that list, and then again, if you shift enter that, you see we can start decorating the plot by drawing the t and the f of t here. For ease of readability, I like to actually go ahead and put a little enter there between, so I see the top line is actually where most of the business logic and interesting behavior is, and then I'm going to start listing out some plotting options. In fact, if you want to make it even more readable, we can even go ahead and add a couple more white spaces and maybe add a comment here saying here is the plotting options here. So again, we're decorating the plot at this point, and we can keep going ahead and decorating more. So for example, maybe I want a title to this here. So I could go ahead and label the plot. So I'll say plot label, and then I'll put the arrow here. So dash greater than, and if I hit a space, that will convert properly to the right arrow that it needs here. And I'm just going to go ahead and add a title here. So the title for this plot might be a simple function using the, how about the plot command. And if I go ahead and shift enter that, we go ahead and we see that we now have a title. We could also go ahead and how about let's turn on the grid lines here. Maybe I would like some grid lines on the back, so I can go ahead and put another comma here and just say grid lines, and then let's switch this to automatic. And if you shift enter that, you see we start getting some grid lines. What else could we do here? We can change how this function is plotted. So it doesn't have to be this normal blue line. We could go ahead and I'll put another comma in, and let's go ahead and change the plot style. So I'll say plot style, and then you can change this to something like, I don't know, orange. And now we have an orange line. And in fact, if you want to change more than one thing, instead of just making it orange, maybe we want it to be dashed or a little bit thicker. So instead of just specifying one plot style, I'll enclose this in as a list. And I could say now I'd like it orange, I'd like it dashed, I'd like the thickness to be a little bit larger here, maybe like such here, and you shift enter that, and now you see we end up with a orange dashed thick line here. One other thing that I want to bring to your attention here is let's choose actually maybe another function f here to plot. So instead of t times cosine of t, let's go ahead and plot maybe something like, how about e to the minus t times cosine of t. So if we shift enter this, here's what we end up with. And you see, one of the issues here is that Mathematica tries to be intelligent about how it sets the axes. So you're seeing it zooming into where it thinks a lot of the action is, but you can see it's cut off the beginning and sort of this middle portion of the plot here. So what I can do now is I can specify and tell Mathematica, you know what, I want you to have the entire range of the plot shown. I don't want you to zoom in. So what I'll do is I'll add another plot option here and say plot range, and set that to all. So if you do that, you see that it now will show the entire plot range here, and you get the entire graph here. So again, this is a very common issue here, and the way to fix it here is just to say plot range all. So, all right, again, let's go back to that original function because I think that was a little bit easier to look at, t times cosine of t, and again, we'll shift enter that, and we have our nice function here that is nicely decorated. Now, what if you wanted to include more than one data series on the same set of axes? Well, Plot can actually handle that. So let's go ahead and start ourselves a new text section here and talk about adding multiple functions to the same set of axes. So what I can do here is, again, I'll call plot here, but now instead of just specifying one function, I'm going to give it a list of functions that I would like to plot here. So I'll start my list with my open curly brace, and then let's do the same t times cosine of t as the first function. But now I'll add another function that I want. Maybe how about 2 times sine of t minus pi over 2. Right? And then I'll close my list here. So these are my two functions, or my list of functions that I would like to plot. And then I will again put a comma in here and then list the domain over which I would like to plot these functions. So I would like t to run from 0 to 2 pi. And if I shift enter that, you see that here we are. It draws me both of those functions on the same set of axes. Now, what we may want to do here is you might want to add a legend here so you can see which one is which. So again, I'll put a comma in here. I'll put a little bit of white space and maybe a small comment in here to say I'm going to start listing some plot options. So we could do things like, again, I could go plot range all here, but I really don't think I need this. It looks like it captured the range of both of them sufficiently, but it doesn't hurt to add that. But what's more interesting is let's go ahead and say plot legends here, and let's go here and choose expressions here. And if you enter this, you see what happens here is we're able to quickly now add a legend here, so we can see that the blue curve is the t cosine of t, and the orange curve is the 2 sine of t minus pi over 2 here. So this is a real quick way to use plot to generate a graphic with multiple data sets on the same set of axes. Now, however, there are a couple of disadvantages to this approach here, right? So if you think about this, one problem here is that the domain of the functions must be the same. Right? In this example here, we see that both the blue and the orange curve have to be plotted over the range of t going from 0 to 4 pi. The other disadvantage here is it's difficult to control the plotting style of the two data sets. So Mathematica just chose to use a blue line for the first one and an orange line for the second one. It would be a little bit difficult if we wanted one of them to be like a magenta dashed line and the other one to be a thick green line. It's a little bit hard to manipulate both of those traces separately here. Finally, the third disadvantage that I can think of off the top of my head here is there's not a lot of legend control. So you see here that we were able to add a legend, but what if the blue curve was something like temperature of a fish bowl and the orange curve represented the population of fish in that bowl? Well, you see it's hard to actually add a descriptive legend here using this plot legends option here. So there's a better way in Mathematica if you would like to actually overlay multiple plots on the same set of axes that are going to address some of these disadvantages here. So this leads into a discussion here of the show command. So let's go ahead and start ourselves a new section here. And again, we'll change this here to a section here and talk about the show command. Show will allow you to generate a composite plot or graphic from multiple subplots. So to use this, what you first do is create a plot of the first function and get it just the way you like it. So for example, let's go ahead and say plot t times cosine of t. This is the example we had earlier, t running from 0 to 4 pi, right? Oops. And let's go ahead and maybe change the plot style. We'll get this thing exactly the way we'd like it. Maybe let's go ahead and plot this thing in orange and a dashed line here. So this is our first plot, so I can shift enter that and see, yep, this looks great. And actually here in the same cell, let's go ahead and make another plot call to the second function. That was our 2 sine of t minus pi over 2, I believe. But now we actually don't need this to go from the same range. I could go ahead and make t, whoops, sorry, I missed the bracket there. Let's make t go from 1 to, how about 3 pi? And again, let's change the plot style here. Maybe we'll make this thing green instead. Okay, so here's our 2 separate plots. Now what I can do here is let's go ahead and actually we're going to assign the output of this first plot to something called maybe, how about plot 1? And similarly for the second, let's assign it to a variable called plot 2 here. And if I shift enter those, we've now created variables plot 1 and plot 2, which are effectively these 2 graphics. Now what I can do is finally I'll call show here and pass it plot 1 and plot 2 to generate a composite plot out of those 2 subplots. So if I shift enter this, we see that these first 2 graphics are the individual plots, and the third output is the show command, which has put the 2 of them together in the same set of axes. So these first 2 here, we might want to actually suppress the output of these or not have Mathematica draw these 2 plots, because we see that they're actually intermediate steps to getting our main composite plot, which is what we're really interested in. So let's come up here and we'll actually put semicolons on these first plot 1 and plot 2 commands. So when I shift enter this, we are only left with the single show command. Now, what we might want to do here is we can start adding plot options here within the show command. So for example, I'll put a comma in here and maybe let's get some more white space to make this a little bit more readable. And let's go ahead and say plot options for the composite graphic. Right? So we could do things like we did earlier, like I could go ahead and make the plot label. Let's go ahead and say that the title of this plot here is multiple plots using the show command. Right? We could go ahead and set the axes label if we wanted to. Again, let's maybe make this, the x-axis should be labeled as t, and then the y-axis should be labeled as f of t. And make a note here that I'm being very careful with all of my closing parentheses and lists and square brackets, things like that. You can quickly get into a situation where you make 1 or 2 small mistakes and it's very hard to debug. So I'm going to try to be very meticulous about this. So again, let's do all of our normal plot options here. Maybe also let's do our grid lines. How about? Whoops. Going to automatic here. All right, so now if we shift enter this, we see, all right, this plot is looking great. So at this point, I think we've gone ahead and addressed these 2 disadvantages, namely making it so that we can have domains over different ranges, as well as controlling how each one of those 2 traces are displayed. Let's talk about this third one, about adding legend commands, or a controlled legend to this here. So in order to do that, what I can do here is I'm going to wrap this entire show call, this show function, in a legended call. So I'm going to go ahead and go legended, and I'll put a bracket, square brace in here, and I'm going to try to use a little bit of white space to make this a little bit more readable here. So again, this is now the closing brace for the legend command, and we see that what we need to do is actually add some additional options. So I'm going to put a comma here after the show command here, and now what I can do here is I'll put a small comment that says add legend information here. So now the other argument that needs to be passed into the legended command is a type of legend. So I'm going to go ahead and use a swatch legend here, and I can see that I'm going to make an orange swatch and then a green swatch, and then what I can do here is I can label the first one, as we said earlier, the orange maybe represented temperature and the green represented, how about, population. So I'll, again, be very careful with all of my closing braces and whatnot. Mathematica, again, will hopefully try to give us some color cueing to make us a little bit easier to know what we're missing or what's deficient. But now, if I run this entire command here, we see this one cell is actually doing quite a lot here, but it gets us the result we want. So maybe it would behoove us to maybe walk through this entire cell just so we understand it here. So again, these first two lines are basically making the two subplots and getting them exactly the way we'd like it. We then assign the output of those two subplots to variables, namely plot 1 and plot 2, and then we suppress the output with semicolons so it's not drawn to the screen. Next thing that we do here is we called show. We use show and just passed it plot 1 and plot 2, as well as set up all of the axes here to get the plot, the composite plot, looking the way we want it to. Finally, we wrap the entire show command, which I'm highlighting here. This is the entire show command. We wrap that in a legended command and tell it the appropriate labels for the legend here. And that's how we're going to make our nice composite labeled legend here, which addresses all three of the disadvantages of using the normal plot command. All right, so the next class of 2D plotting functions I'd like to take a look at are, instead of plotting continuous functions, what if we had a discrete data set that we wanted to plot? So let's go ahead and start ourselves a new section here, and let's talk a little bit about the ListPlot command here. So like we said, ListPlot is going to allow you to basically plot a list here or a matrix here. So why don't we go ahead and make just a single point in 2D space? So let's call it point 1 here, and I'll use my discussion here or our notation here to generate a simple matrix, right? This is a row matrix here, right? It's just 1, 2 here. And now what I can do here is let's go ahead and just call ListPlot on this data here. So my data set is very simple. It's just a single point here, and you see what ListPlot does is it just generates a single point, as you might expect. So you can obviously do things that we talked about earlier, like you can still have plotting options here. So if you want to change how this is displayed, we can change the plot style. Maybe we would like this to be a green dot here. So there's now a green dot. Again, we could make multiple parameters, so we could change the point size to be something, maybe I'd like it to be a little bit bigger. So now here's a big green dot. And as you can probably imagine, though, one dot is not very interesting, so maybe we should look at multiple data sets. So maybe let's make another variable called points here. Let's make this a larger matrix here. So how about here's one point at the coordinate 1, 2, another point at the coordinate 2, 3, another coordinate at the point 3, -1 here. So again, I'm just going to use my shorthand notation for inputting a matrix. Again, if you're not familiar with working with matrices in Mathematica, please check out the video that we posted earlier that talks about working with matrices in Mathematica. But again, points right now should just be a 3x2 matrix. But if we go ahead and do our list plot of points, we see that we now get all of these points showing up simultaneously. And again, maybe let's also make these as big green points. So I'll go ahead and add some plotting options here. There we are. Now, you might want to connect all of these points together with a line. So if you're familiar with plotting in, say, MATLAB, what MATLAB does is you give it a bunch of points and it will connect them with a straight line. So you can actually do that here with LisLintPlot here. And it will draw a list of points. And now this might be interesting to show that, you know, what we could do is we can go ahead and assign these to a variable. Maybe let's call this plot A, and then shift enter that. We'll call this one plot B, shift enter that. And then we can go ahead and use our show command on plot A and plot B. And you can put both of these one on top of the other. So again, this is helpful because now you can start recreating things like how MATLAB does things, right? By just plotting a bunch of data points and then connecting them with lines. You know, why don't we look at a more complicated example of ListPlot here that might represent something you might actually encounter in an engineering scenario. So let's go ahead and make some data here. So let me go ahead and make a comment here. I want to make some fake data here. So I'm going to go ahead and use table to do that. And let's just maybe make this, I would again like this to just be a 2-column matrix. The first column might be like, say, time, and the second column might be some data, like maybe it's 2 cosine of t, but then let's add some random noise on top of this. So random real will give me a number between 0 and 1 with the uniform distribution, but you know what, let's subtract off a half, so I'm adding noise plus or minus 0.5 to this signal here. So that's my matrix here, and you know what, let's make t go from 0 to how about 4 pi, and maybe go with, I don't know, maybe let's do divisions of something like that. Okay, so here, this is going to be my data here. Again, if I want to look at this in matrix form, we're going to see that what this is looking like, it's just a boatload of data here. The first column is time, the second column is data associated at that current time. So this might be something that you might encounter from, say, a data acquisition unit or something like that. So again, you might just go ahead and say ListPlot data. And as you can see, here's my noise. And what I might want to do here is, again, let's assign this to a data plot here, or a variable called data plot. So here we go. And then what we can do here is I could make another plot of what the underlying carrier signal was supposed to be, right? It's supposed to be cosine, 2 cosine of t, going from t equals 0 to 4 pi, right? And maybe we want this thing to have a plot style of red, something like that. And what we'll do is assign this to a variable called, how about FitPlot? Because this is the fit of the data. What did I actually end up doing here? Let me see. Oh, that didn't come out quite right. Plot style, what did I... Plot 2 cosine of... Oh, whoops, sorry, there's an extra t there. There we go. Okay, plot cosine of 2t. There we go. Okay, plot style of red. There we go. All right, and maybe, you know, let's make this a little bit thicker too. Just I like the lines to be a little bit thicker. Okay, so there we go, thick red line. And now let's just go through again, adding these two plots together using show and adding a legend just to get a little bit more practice. So again, we'll go ahead and do show on the data plot and the fit plot. So this is the very simplest situation that we've got here, is we can go ahead and add two figures. But then again, within the show, I'm going to go ahead and add some plot options. All right, so we can go, again, do things like axes label of something like t and then f of t. Maybe we'll turn grid lines on. Grid lines to, oh, come on, I can type here. Grid lines to automatic. Yeah, that looks pretty reasonable here. And now what I would like to do here is add a legend to this. So I need to wrap the entire show here in a legended call. And then down here, I will add legend information. So we've got we'll add a swatch legend here, and this is going to be blue and red, and the blue represents the data, and the red represents the best fit. Okay, so if I close everything, oops, sorry, and I missed the closing to the legended. There we go. Here we go. So now we've got our realistic data plot here. All right, so let's take a look at another function called DiscretePlot. So DiscretePlot is helpful if you have a function and you only would like to look at it at, or plot it at specific values of that function here. So for example, what if we wanted to plot sine of x with x every 10 degrees or something like that, right? So if you go ahead and plot sine of x running from 0 to maybe pi over 2, right? This is not what we're looking for, right? This gives you a continuous plot of the function here. If I really want to represent this with just discrete values, instead what I'm going to do is I'm going to call DiscretePlot and give it the function here, again, sine of x. And let's say I want x to go from 0 up to pi over 2 using steps of 10 degrees. So obviously I need to convert that 10 degrees into radians here. So if you do that, you see we end up with the discrete version of that continuous function here. Now, DiscretePlot is nice if you want to do things like draw cumulative distribution functions for, say, probability. Basically, I'm saying you can jazz up this DiscretePlot call if you'd like. So again, let's do the exact same thing we had earlier. Let's pull up this DiscretePlot. But again, just like most of our plotting functions, if you put a comma in here and then you can start adding additional options. So for example, we could change the extent size. And let's make this go to the right. See, and if you shift enter that, you get this result here. You could also change like the extent markers. Oops, extent markers. So we could make this go from a filled circle on the left side to an empty circle on the right side. So if we enter that, you see that we end up with these circles to kind of delineate on these locations where it appears the function has two values. You can pick one specific value here. So again, DiscretePlot is helpful for operations like that. All right, so let's take a look at maybe two more quick two-dimensional functions for plotting. So the first one here is a histogram. So to do that, let's go ahead and make some more data here. So again, I'll use my table function here, and let's just get just a bunch of random numbers here. Maybe let's just get, I don't know, 1,000 of these random numbers here. So again, all data is here, it's just it's a 1D table here, or a 1D matrix. So if I look at this here, data 2 slash, well, actually this is going to be a little bit ridiculous, but I think it'll give us the idea, right? It's just a one column matrix with 1,000 elements, and every single element is just a random data sample here between 0 and 1. Well, if I want to visualize that, you can use the histogram function here to visualize that. So here you go. Here's a histogram of that data set. I don't think it warrants too much other discussion. Again, there's plenty of other options on how you can change this histogram. So feel free to explore that at your leisure. And then maybe the last one that I'd like to quickly point out and draw to your attention is more for fun rather than for actual engineering here. But I just thought I'd show you that, you know, Mathematica has a wide variety of two-dimensional plotting functions here. So the last one here is PieChart. And as you can imagine, this one is really simple, and it just makes a pie chart here. So if you just give it a bunch of values, 1, 2, 5, something like that, and shift enter that, you basically get a pie chart representation of that data set. So with that, I think that covers most of the 2D plotting that I would like to talk about in Mathematica here. Let's take a quick look at a recap or summary to talk about what we covered today. All right, so to summarize, what we talked about today was we first started out by looking at the plot function in Mathematica, and we saw that really was the workhorse for generating most of your two-dimensional plots in Mathematica. I use this for probably 90% of my plotting needs. We also talked about, in addition to just using the baseline plot, we showed how to do things like adding axis labels, titles, grid lines, legends. We also talked about the axis limits as well. But basically, all of this was how to manipulate your two-dimensional plot to get it to look the way you wanted. We then took a look at the show function, and we saw that show is going to actually allow you to combine multiple graphic objects on the same set of axes. So it's really nice when you want to combine two sets of data series on one plot. And we saw that you can actually even combine dissimilar types. You could add list plots with normal plots with any other type of graphic here. So it's actually very versatile. In addition to the continuous plotting functions, we looked at some discrete ones like using ListPlot, as well as some other interesting 2D plotting functions like DiscretePlot, Histogram, and PieChart. So, I hope you enjoyed the video. If you did, please subscribe to the channel. You can do that by clicking on the icon that should have just shown up on your screen. We'll have lots more videos on Mathematica and other topics of interest in the near future. So, I hope to catch you at a future video. Thanks so much. Bye.